Hi everyone. Okay, we got the practice test we'll go through. Let you see a video on this and see how we do. Number one, it says let f of x equal x to the fourth minus 3x to the third plus 5x minus 3. Use synthetic substitution to find f of negative 2. Alright, now if I want to find the actual value of f of negative 2, I use negative 2 in the box. And I got 1x to the fourth minus 3x to the third. I'm going to put a 0 for x squared. We need every power taken care of. Plus 5x and minus 3. And draw my line. Bring the 1 below the line. Negative 2 times 1 is negative 2. Bring it up here above the line. Add. Negative 3 plus negative 2 is negative 5. Negative 2 times negative 5 is positive 10. 0 plus 10 is 10. Negative 2 times 10 is negative 20. 5 plus negative 20 is negative 15. And negative 2 times negative 15 is 30. 30 plus negative 3, negative 3 plus 30 is 27. So I'm going to write my final answer as f of negative 2 equals 27. And I use synthetic substitution to get that answer. Alright, number 2 is the same type of question. So put a 3 here. 2x to the third minus 5x squared minus 22x plus 5. Just writing the coefficients there, not the x's. Bring down the 2. 3 times 2 is 6. Negative 5 plus 6 is 1. 3 times 1 is 3. Negative 22 plus 3 is negative 19. 3 times negative 19 is negative 57. 5 plus negative 57 is negative 52. That's the answer. F of 3 equals negative 52. Number 3. Given that 2x cubed plus 15x squared plus 22x minus 15 has a factor of x plus 5, use this to find the other factors. Alright, well I'm going to divide. I'm going to divide this by x plus 5, but I'm going to use synthetic division. We're going to do that a lot in this test. So I got the 2, the 15, the 22, and the negative 15. And I hope I get 0 from this. If I don't, we've got to look at another route. 15 and negative 10 is 5. Negative 5 times 5 is negative 25. 22 and negative 25 make negative 3. Negative 5 times negative 3 is positive 15. I got 0 there. So I'm looking at 2x squared plus 5x minus 3 times x plus 5 will give me this, because the remainder is 0. And it says find the other factors. If this is factorable, I would like to keep going with it. So I want to check what multiplies 2 times negative 3 to negative 6 and adds to 5. And I believe that that would be 6 times negative 1. Multiply, you get negative 6. Add, you get 5. So I'm going to come up here and write 2x squared plus 6x minus 1x minus 3. The reason I wrote that's how I'm splitting up the 5x, and I'm going to factor by grouping. And 2x times x plus 3. 2x is a common factor of 2x squared and 6x. And then I'll put the negative 1 out here, because that's all it'll go into there. And I'll put negative 1 times x plus 3. If I distribute, I'll get this. So x plus 3 is that common factor, and that's good. So 2x minus 1 is an extra factor, another factor. And x plus 3 is another factor. So our factors in linear terms is x plus 5. That was the one we were given. And we found 2x minus 1, and we found x plus 3. We multiply these three binomials together, we will get that answer. All right, number 4. Given that we get the same kind of given that x cubed minus 4x squared plus 10x minus 12 has a factor of x minus 2, use this to find the other factors. Okay, I'm going to put 2 here in the box. So 1, negative 4, 10, negative 12. Bring down the 1. 2 times 1 is 2. Negative 4 plus 2 is negative 2. 2 times negative 2 is negative 4. 10 and negative 4 makes 6. 2 times 6 is 12. All right, it is a factor. When we get 0, yes, it is a factor. We have x squared minus 2x plus 6. Well, what multiplies to 6 and adds to negative 2? Well, let's see. 6 is 3 times 2. Negative 3, negative 2, negative 6, negative... Nothing's going to work. I can't get that to work. So we don't have a linear way of breaking that down. So let's just write x minus 2 for the one they gave us. Let's write this one as x squared minus 2x plus 6. When we're just looking for factors, we'll stop there. All right. Now, number 5 and 6 give the number of positive real zeros, negative real zeros, and imaginary zeros of the function. Okay, so I'm going to graph. Y equals x to the third minus x to the second minus x minus 3. I'm going to graph that. All right, I think I need to change my window here a little bit. All right, actually I'm going to hit zoom, and if I hit zoom and then number 6 to the standard there, it'll give me the negative 10 to 10 and negative 10 to 10 there. That looks like a good one. It looks like I got a positive real zero right here, 2 point something or other. I don't see any negative real zeros. And it's a degree 3, so I'm going to count that we have 2, so that 1 plus 0 plus 2 needs to add up to 3, or we need to have some sort of accounting of that. Okay, number 6, y equals 2x to the 6th plus 5x to the 4th minus x to the third minus 5x minus 1. Graph that. There it comes. All right. As I can see here, I don't think we're going to cross anywhere else, that this looks like a negative real zero. I think we got 1 there. This looks like a positive. We got 1 here. And I think we got a whole mess of imaginary zeros. I need 6 zeros. There's 1, 2, plus 4 makes 6. So to account for all 6, I think the other 4 are imaginary. Now number 7. We're going to start with a graph, give all the exact zeros. So we got to find some of them here. So I'm going to use x to the 4th. Let me clear this one. X to the 4th minus 2x to the 3rd minus 12x squared plus 14x plus 35. Let's graph it. Got 4 zeros here, and we're looking for the exact zeros here. I'm going to zoom that in. I'm going to change the window a little bit. I want to change the x from negative 5 to 5, just so to widen out the x-axis a little bit, so we can see where that is crossing. Okay, well, that is interesting. I am going to look at a calc function You wouldn't have to do this on Desmos. Left bound. Let me look for something over here. Hit enter. Go down there and hit enter. Okay, that one doesn't look like it's a rational one. So I'm going to try another one. Second calc, 0. Let's go here, enter, and here, enter. Not looking well, not looking as rational as I thought it would be. Okay, let's try these positive sides. 0. Alright, so it comes into view here. There we go. Hit enter for left bound. For right bound, hit enter again. All right. Well, I was really hoping we'd find something a little more, hit enter, than what I found here so far. Okay. Okay, we have 4 zeros, and it doesn't look like any of them are rational. So let me just check to make sure I put this in right. X to the 4th minus 2x to the 3rd minus 12x squared plus 14x plus 35. Okay. Hey, I'm going to skip that one and go to number 8 here and try to write a better problem on the test where we can have at least some that are real, not real, that are rational numbers instead of just irrational real numbers. Okay, so let's try number 8. All right, I'm going to take y equals 2x to the 3rd plus 5x squared plus 5x plus 2. Graph that. All right. Looks like we might have something here at -1. And I could use the 0 function if I want, but it might be just as quick just to try synthetic division, see if we get 0. So put the 2, and -1 times 2 is -2. 5 and -2 make 3. -1 times 3 is -3. 5 and -3 is 2. -1 times 2 is -2, and that is 0. So we've got now 2x squared plus 3x plus 2. And I'm going to set that equal to 0. I just was thinking real quick, if I multiply the 2 and 2 together to 4, what multiplies that and adds to 3? And if it's +4 and +3, I don't think anything will work. So I'm going to use the quadratic formula and have x equals -b plus or minus square root of b squared minus 4ac, all of that over 2a. And a here is 2, b is 3, and c is 2. So it's -3 plus or minus the square root of 3 squared minus 4 times 2 over 2 times 2a, 2. All right, that looks like -3 plus or minus the square root of, this is 9, 4 times 2 is 8, 8 times 2 is 16. This is 9 minus 16. So that is negative 7. All right, well, that's why none others showed up, because that's not going to be real over 4. And I am looking at negative 3 plus or minus. Now, the square root of negative 7 is I radical 7. Just pull the negative off and put an I on the outside. Square root of negative 1 is I. That's why we can do that. That's by definition. And all of the exact zeros would be negative 1. That's one we found from the graph. Negative 3 plus I radical 7 over 4, and negative 3 minus I radical 7 over 4. Okay, there's my 3 solutions there.